Well, we're back here at the Hall of Science, Cave of Science, I should say, and a little bit of the review for the first 9 weeks. Remember, the 18-week end of semester exam will also include material from the first 9 weeks of the semester. It's about a 40 to 60 ratio, 40% of the first 9 and then 60% of the second 9. Well, make sure you know the Newton's laws of motion will be on there. We're going to be able to calculate density. You have a density problem on there. The other problem you're going to have is wave speed. And again, these are all calculations that we did. The other calculations you're going to need to be able to do are speed or velocity, and I'll write down velocity. You're going to need to calculate acceleration. You're going to need to calculate KE, GPE, force, momentum, and these are really going, oops, I don't want that. And these are really going back to the rocket project. Excuse me. Spent a lot of time on the rocket project, and these are the all the calculations you're going to need to do. So I'm going to give you a scenario, and then you can go ahead and work on those. And I'll throw a key out, probably another week or so. All right, so let's look at a scenario. And we all did this earlier in the year. Let's say we got our rocket. Whoops, get it up here, put some fins on it, and we launched our rocket from the ground, and our rocket flew to a height, and then it came back down. And we can put on USA on here. Alright, so we're going to need to calculate all those things on the previous page, and we're just going to concern ourselves with just the calculations going up to the altitude. So we're just going to concern ourselves here. So we just want it as it's flying up. We're not going to worry about any of the calculations coming down because they're just repeats of the ones going up. So we need some parameters to work with here. Remember, you also have a density problem. So we're going to say our mass of engine. Our mass of engine. And again, I'm just making up these values, so they could be any value. Is 16 grams. The volume of the engine. Volume of engine. And let's say, I don't know, let's just say it's 10 cubic centimeters. So make sure you can be able to calculate the density of the engine. And let's say our rocket flew to an altitude of 120 meters, and it took 5 seconds. Let's see, so time is 5 seconds. And let's say our rocket had a mass, so we got rocket mass, about 0 0.32 kilograms. So there's essentially what you did in the rocket project. So we have an altitude of 120 meters, time it took to go up 5 seconds, and the rocket's mass is 0.32 kilograms. So again, we're just going to look at it on the ascent. We're not going to worry about on the descent at all. And so when you do this, go back to the previous part there, calculate acceleration, velocity, KE, GPE, force, momentum, and then also calculate the density of the engine. And have some fun with it. Like I said, I'll put a key out the next week or so. But this and Newton's laws of motion are going to be the first 9 weeks of the semester exam. So have some fun with it, and we'll talk to you later.